Okay, we have this golf equipment manufacturer. So they are making golf bags. They're going to make golf bags. And the distributor is going to buy all the golf bags that PAR produces. So this means we don't have to worry about the limit of the market demand. So there's no worry about the constraint there. Here are the operations that are needed to make the golf bag. You gotta cut and dye the material, you gotta sew the material, finish the material. That means like steps like this, and then inspect and package the package. So the final product is going to look like this without the golf clubs. And there's two models here. There's a standard bag, medium price standard bags, and then there's also the deluxe version. So we've got the standard version and deluxe version. And they want to decide how many of each to produce. And then we have some kind of recipe here, like how much resources do these bags require. So medium price standard bag require cutting and dyeing department 7/10 of an hour. Okay, so 0.7 hour. Okay, and the sewing takes half hour. Finishing takes an hour. And inspection and packaging takes only 1/10 of an hour. And so here are the times that you need to spend to make one golf bag. And then the deluxe bag, we have the times for that too. 1 hour, 5/6, 2/3, and 1/4 of an hour. Okay, so so now they have a limited number of hours available at these departments, and we are told that here are the limits. Cutting and dyeing, there are 630 hours available. Sewing, 600 hours. Finishing, 708, and 135 hours for inspection and packaging. So here are the limits. Okay, so we have limited amount of hours to spend on these things. So we're trying to make as many as possible, at least make as much profit as possible from these bags. So the decision is, okay, how many standard and how many deluxe bags should I make to maximize my total profit out of these two kinds of products? Okay, so there's like a lot of data given here. First thing you want to do is usually you want to organize the data. I did it for you here. So I put all this together. And I put here two kinds of products, so standard bag and deluxe bag, and the resources that are used in the different kind of departments, cutting and dyeing, blah, blah, blah. So there's four departments. I put them in the rows. So usually the resources go here in the rows, and you have the products, like what you're making, the outputs go in the columns. And then for each department, we have the available hours that were given from here. I just list them here. And then we have the numbers, like how many hours you need for each bag, that kind of information. I put them in here, inside. So standard bag, okay, here's the information from this paragraph. Deluxe bag, break from here. So this information is entered here. And finally, the profit is a $10 and $9. I put them in the bottom. Okay, so now we understand, right? So where all these numbers come from. So now we're going to put these together to come up with a linear program model. So we're going to write down all the math, all the formulas that correspond to this. We are making two things. Okay, decide how many standard and deluxe to produce. Okay, so that is what we're trying to do, and we want to maximize our total profit from it. Okay, and then we have certain constraints. And so the first thing is let's give names to these guys. So we're going to say we're going to have designate two variables because there's two quantities we're trying to decide on. So standard bag, number of standard bags, and number of deluxe bags. Okay, so we're going to say let S, because it's standard. S for there, standard. S, and then the other one is going to be called a D for deluxe. And so it's like XYZ, but instead of using XYZ, we're going to use the first letter of the product, so it makes it easy for us to remember. So S is equal to number of standard bags to produce. Okay. And then we're going to have a D, number of deluxe bags to produce. So let's try. S is equal to 100 and D is equal to 100. And then we're going to try to calculate the profit out of this. Then what is the total profit? Okay, well, total profit is the sum of profit from standard bags and profit from deluxe bags. Okay, so let's see, we're given some amount here, $10 per unit. So if you make one standard bag gives you $10, and the deluxe bags is $9 if you make one deluxe bag. Now, what if you make 100 standard bags? How much money do you make from that? From 100 standard bags, how much profit do you make? 1,000, right? So it was 10 times 100 is $1,000. Okay, so this is the profit from 100 standard bags. In a similar way, of course, we could do the other one. Deluxe bags, profit from that is 10, not 10, but 9 times 100 is $900. So that's profit from 100 deluxe bags. Okay, so then we're going to add them together. So total is 1,000 plus 900, so it's 1,900. So what we have is, if you make 100 of standard, 100 of deluxe, then we're going to make $1,900 in total profit. Okay, so now how do we get this? How do we get this? We took the S, the 100, multiplied it by 10, right? So we did like 10 times S, right? The 100 that's the S. And then we did 9 times the D, 9 times D, and then we added them together. We added them together. And so here is our little mathematical formula. We have figured out the formula for the total profit, 10S plus 9D. So what we did is we did this part. We wrote down the objective function in terms of our decision variables. So 10S plus 9D, right, that is your objective function. And we defined the decision variables. So we have the S and D that we defined. So we did 1 and 2. And then now we're going to write down the constraints, the formula for the constraints in terms of our decision variables. Okay, so now the constraints. Now let's go take a look at the constraints. So now what are the constraints? All these are going to become our constraints. So there's limits to all these resources. So there are 4 limits. So we expect to have 4 constraints. Cutting and dyeing. Let's talk about cutting and dyeing. Okay, so we're going to ask, so what we want to do is the number of hours used must be less than or equal to available hours. And it's the same situation for each one. We have limits on how many hours we could use. So we could express it as number of hours used must be less than or equal to the limits, the available number of hours. Okay, we have the available hours all here, like the 630 for cutting and dyeing. So we just figured out how many, this expression, number of hours used. Okay, so again, to make it a little bit easier for us, let's try this and calculate number of hours used for cutting and dyeing. So if we're to make 100 of each, then how many hours are we going to use in this department, in cutting and dyeing department? Okay, so one standard bag is going to take you 7/10 of an hour. Okay, so say one standard bag takes 7/10 of an hour. So if I do 100 standard bags, then we know what's coming. So then it's going to take 100 times 7/10 of an hour, right? So 7/10 times 100. So that's 0.710, so like a 70, right? 70 hours. Now, what about deluxe bag? Well, one deluxe bag takes, what's that, 1 hour? 1 hour, so 100 deluxe bags will take 1 times 100 is 100 hours. Okay, so now the total amount of hours, we would have to sum these separate hours. So 70 plus 100, so total hours used is 70 plus 100 is 170 hours. So this is how we would calculate the left-hand side, the hours, total hours used. And so now and then, instead of using the numbers, we're going to kind of plug in the letters. And so S. So we're going to make it kind of more general. Okay, so here, how did we do it? We did 7/10 times 100. That was the amount of S. And then here we did 1 times this amount. So 1 times D. So that is the 170 hours. So this part. So this is the left-hand side. Over here, number of hours used. Okay, so we could say all this less than or equal to, and the available hours, we just take it from here, 630. Okay, now do I have to do this for each one, for each department? Do I have to go through all this for each department? Oh, don't make me do it. No, we don't want to do that. So because these are really the same format, all the same kind of constraints. Hopefully, if you do it once, you should know how to do it for the others, and you just follow the same pattern. So here I could see that's 7/10 times S plus 1 times D less than or equal to 630. Okay, so here we're going 7/10 S plus 1 times D is less than or equal to 630. That's for the first constraint, and we just do the same thing for all the other constraints. Okay, so I think we are ready to write down, write down the entire linear programming model. And so just similar for other constraints. Okay, so we're going to go, let's see. So let's go over here. Okay, so we're going to start with maximize the total profit. So that's our objective. So on the top, we got to have our objective function. And then we follow with the constraints. So when I say maximize total profit, what's the total profit? Right over here. 10S plus 9D plus 9D. Then we say subject to, and then we follow with our constraints. So the first constraint was like this, 7/10 S plus 1D less than or equal to 630. Okay, so 7/10 S plus 1D less than or equal to 630. And now we just, I think you guys know how to do it. So just copy this, copy all this down. And have S plus 5, 6D less than or equal to 600, blah, blah, and then, okay, and 1S plus D less than or equal to 708, then 1/10 S plus D less than or equal to 135. Okay, right? So just using these numbers, and then, so now the thing to think about is, okay, can you? Is it possible to produce a negative amount of something? So can we say, we plan to produce negative 100 of the standard deluxe or standard bags? So it's not possible to produce like negative number. So we know that, but computer doesn't know that we can have negatives for these values. So we have to explicitly say no negatives. no negative production. No, don't produce in negative quantities. So we want to say something like, so negative. So we'll say S and D not allowed to be negative. So this is another constraint that we want to specify. So SD, so that would be like saying S is greater than or equal to 0, and D is greater than or equal to 0. Customary thing is to just kind of put these in one line, something like this, S, comma, D greater than or equal to 0. So this is meaning both have to be greater than or equal to 0. S greater than or equal to 0 and D greater than or equal to 0. This is a very special thing because it's our first linear programming model that we created. Okay, so let's talk about the components of this linear programming model. And so what do we call this? This part is called objective function. Objective function. Okay. So whatever you're trying to maximize or minimize, that's our objective function, right? And then all this stuff. What do you call these again? It's constraints. Constraints. Okay, now this constraint is a special kind of constraint. So it's something that we just tack on to make sure that we don't have negative results at the end. And so we call this non-negativity constraint. Non-negativity constraint. Okay, and now these values like this 10 and 9. Remember we said these kind of numbers are called coefficients, right? So all these numbers are called coefficients. Now the coefficients in our objective function is more special, and we'll call it objective function coefficients. So the 10 and 9 are called, we'll just say OBJ for short, objective function coefficients. Okay, and then these kind of numbers, like numbers on the right-hand side, and these numbers are special. And because they're on the right-hand side, let's call them right-hand side, or RHS for short. So right-hand side. So right-hand side values. So that's these values. Okay, so like this part, we're going to call them left-hand side, just so that we have some name for them. So this is how we would write down a linear programming model. So this is a really, really important step, because this is something that we have to do as humans. So we have to do, and then so that we could feed it into our computer, and the computer could solve it for us.